Our very first STM32 Blackpill project. It's the power behind this HS101 Pro oscilloscope in a small aluminum box, 80 by 50 by 20 millimeters. These things are very quiet, and I have a small demonstration to show you just how quiet they are. We're going to put the Blackpill HS101 Pro up against the Handtech 6022BE. Now the 6022 is very representative of budget oscilloscopes, and it's been used extensively here on the Gadgets playlist. And it's the simplest of tasks. Both of those oscilloscopes will be asked to measure the voltage of this AA battery. It's not a power supply or a waveform generator, so any noise that is introduced comes from the oscilloscopes. The AA alkaline battery generates no noise. We'll start off with the Handtech 6022BE. Here's what the Handtech 6022 looks like. Peak to peak, 20 millivolts. And now it's going to be the Blackpill HS101 Pro's turn. And with the Blackpill HS101 Pro, peak to peak is 6 millivolts. I've seen it go down to as low as 4. Here it is at 5. It's a quarter of what the Handtech 6022 was doing noise-wise, off of a 1.5 volt alkaline battery. Do not underestimate the small HS series oscilloscopes, especially if they have a Blackpill installed in them. This is the most advanced circuit that I've worked on the Gadgets playlist so far. It's available for download with the link in the description box. I also include a parts list on this build. Let's have a closer look at this circuit board. Top left hand corner is the AQI 210 relay. It's commanded through the HScope app and has the ability to switch that 104 ceramic capacitor in and out of the input circuit, providing hardware-based AC coupling. A feature like that implemented in this fashion in a DIY build is pretty cool in my opinion. Center of the screen is the 30 picofarad variable capacitor. Its role is to apply compensation so that the square waves have square corners. You can use an external square waveform generator or use the built-in HS101 generator that's available on pin A08. The circuit allows for these two 100 microfarad 16 volt capacitors to be laid on their side. Just a couple of weeks ago I was having a really hard time to get that 6S21 onto an adapter board like that. In that short period of time I've acquired a new skill, like it's a breeze now. Who says you can't teach an old dog new tricks? So where's the Blackpill? Right here on the back. That's a new thing, right? Back-to-back circuit boards, distanced only by the small black plastic separators of the male headers. I want to bring to your attention that small 3.3 volt supply here. It's shown as a red dot on the schematic, and there's no header connecting that 3.3 volt to the circuit board. It's just one of the leads on the trace that is soldered onto that 3.3 volt. We have to solder the bootloader jumper pins ourselves on these Blackpills. That small yellow plastic separator was then pried off. This allows the jumpers to sit right on the board and the top of the pins to be snipped off. It's all about height on this project so that it can fit in that 20 millimeter constraint of the aluminum project box. The firmware flash procedure for the Blackpill is described in Gadgets number 81. The Blackpill is shipped with a 4-pin header that is meant to be soldered at the end of the board, but we don't need it there. I cut it in half, so 2 pins are soldered onto A09 and A10. And then to provide 3.3 volt and ground for the firmware flash process, I just held the other two pins by hand. The key word here is temporary because those two holes have to be kept clean for the board to be able to sit on the headers over here. I then trimmed about 2 millimeters off the fiber at the end of this board to allow the USB to stick out by that much and be able to fit in the end cover of the aluminum box. Speaking of the aluminum box, I just lined it with some blue duct tape. That's to keep it electrically isolated from the circuit boards. You'll notice that the schematic calls for this type of BNC, which is fine if you have the headroom and a project box for it. This slim box does not allow that, which is why I went to this style of female BNC connector and I notched out the circuit board to accommodate it. The leads have been soldered to the BNC and the board has been secured to the box with, you guessed it, a few dollops of hot glue. Note the generous clearance given here. The micro USB of the Blackpill must not make contact with the aluminum housing. Right now, it's the only one of its kind in the world. Which one of you intrepid viewers will make it too? Thanks for watching, guys.